This video is going to show you the answers to the test review to the upcoming test on functions, as well as talk to you through any explanations that you need to understand the problems with so that you can do well on the actual test. For number 1, it is asking you to graph y equals negative 3x minus 2. You actually have two options when it comes to this. It depends on whichever one you are best at, right? Because it does not say make a table or use a certain device, you can use the M and the B and graph it that way if you feel comfortable with it. Or if you don't feel comfortable with that and you prefer to make the table, then you can certainly make the table. So in this problem, the slope is negative 3, the y-intercept is negative 2. So if I'm going to use the m and the b value, I'm going to start my line at negative 2 on the y-axis. There's that starting point. And then I'm going to make my slope into a fraction by putting 1 on the bottom. And now I'm going to rise negative 3 and run positive 1, which means go down 3 and right 1, down 3 and right 1, right? And from that, I can get the line that you see here. Okay, remember you have to have at least 3 dots and you have to have arrows at the end of your line. Right? Now, if the M and the B is something you don't understand or aren't very comfortable with, then you can create your own table, right, to help get you values that'll be on the graph as well. And if you're going to choose table values, you would want to choose the 3 easiest ones, which would be negative 1, 0, and positive 1. And if I plug negative 1 in, negative 3 times negative 1 is positive 3. 3 minus 2 is positive 1. If I stick in 0, negative 3 times 0 is 0. 0 minus 2 is negative 2. And if I stick in positive 1, negative 1 times 3, sorry, 1 times negative 3 is negative 3, minus 2 more is negative 5. And then I can graph those 3 dots. And you'll notice that when I plot those 3 points, negative 1, positive 1, right, it's on the line. 0, negative 2 is on the line, and 1, negative 5 is on the line. So regardless of which way you go through to graph the line, you have to produce the right picture. Right, for number 2, it is asking you to graph the relation that is represented by the table. A relation is just a set of ordered pairs. Right? That does not mean you need to connect the dots. Right? It is just ordered pairs in a table format or an ordered pair format. Right? So for these 3 dots, you literally are just going to graph them and then be done with it. So 3, 0 would be over 3 and stop. There's your first dot. 6, 1 would be right 6, up 1. There's the second dot. 9, 2 would be right 9 and up 2. There's the third dot. You do not need to connect these because it is just a relation. If it said to graph them and draw a line, then you would need to. Okay. For number 3, it is giving you a table of values and multiple choice equations. When it gives you something like this, the best attack for this type of problem is to go through and just start plugging them in. And when you find one that works for everything, that's the one you want. If something doesn't work, then rule it out automatically. So if I stick in negative 1 in letter A behind the X, all right, there's a negative sign already there. So negative 1 makes positive 1, and positive 1 minus 3 is going to make negative 2. And you'll notice that negative 1 doesn't have negative 2, it has negative 4. So that means A is already out of the running. So then you go to B, and you do the same thing. Negative 1, that's positive 1, plus 3. That makes 4. That makes a positive 4. So we need a negative 4. So that means B's out of the running. Right? Then we go to C, and we stick in negative 1 minus 3, we get negative 4. So that's potential. Go to D, if you stick in negative 1 plus 3 is positive 2. So that means that one's out. So just by plugging in the very first order pair in the table, we can already conclude that letter C is the right equation. Right, for number 4, you've got a word problem or situation where you have to create an equation from it. Right? So we've got UPS determining the cost of a package. It's a $2 flat fee. That means you have to pay it no matter what. And then 80 cents per pound additionally. Right? So we want an equation where the P stands for the total cost and the W stands for the weight. Right? So we have to pay the $2. That's a given. And it's not going to change. So that means we can throw out letter B because the W means that 2 is changing. Right? And we can throw out D because that doesn't show us a flat $2. So then we need to decide, are we adding 0.80 times W or are we adding 80 times W? Well, because it's 80 cents per pound, it's written 0.80 times W. So C is the correct one. Letter A would be $80 per pound, which would be unheard of. All right, for number 5, you have to create a table and ordered pairs for the picture that you've got. So the first thing you have to do is plot some points on the graph and then turn them into a table and the ordered pairs. All right, so remember that your points are anywhere that it crosses through the intersection of the grid. Okay, so there should be 4 of these, okay, that you have. All right, so from these four, and you set up your table, you can just set it up as simple as an XY table. You're going to list all the X values, right, and then the corresponding Y values. So start at the first dot. That would be 0, negative, or 0, positive 4. 0 is an X, positive 4 is a Y. Then go to the next dot, which would be 1, 2. So positive 1, positive 2. Then you would go to 2, 0, so 2 on the X side, 0 on the Y side, and then 3, negative 2 would be 3 on the left and negative 2 on the Y side. Right, so those are the tables. Now you're going to take that table and you have to write them as ordered pairs. And that's where you just simply write everything you have in that table as an ordered pair. And that is showing multiple ways to represent the same problem. Right, so use your graph and get those two pieces to happen from it. Right, for number 6, you have a rate of change problem. Right, so on January 4th, Emily's bank account had $1,230 in it. By January 9th, her bank account had $1,015. Find the rate of change. Anytime you see rate of change, you're going to set up your T-table with the words, because this is a word problem. So our time is always X, so that is going to be days. And then our Y value is going to be the money in her account, the balance. So on January 4th, she had $1,230. On January 9th, she had $1,015. And then we have to figure out how it's changing. So from $1,230 to $1,015, that is a subtraction of $215. She lost money. On the day side, you'll never have a negative time frame, so that's adding 5 days. Right? So now when we go to get our answer, we have to set up a division problem. It's always y divided by x. So in this case, it'd be negative 215 divided by positive 5. And when you do that, you get negative 43. And then you've got to remember that you've got to have words behind them. And because it's money in days, it's negative $43 per day. In other words, she's losing money every day that from between January 4th and the 9th. So it must be meaning that she's spending it. For number 7, you're identifying independent dependent variable. You do not have a formula, you just have a situation, right? So Isaiah is comparing cell phone plans. D is the price of the bill every month, and T is the number of minutes he uses each month, right? The price of the bill depends on how many minutes he's using. So that means that the dependent variable is the D, or the price of the bill. Okay, and the independent variable is the time, the T, which is the number of minutes, because the price of his bill is going to depend on how many minutes he's actually using. Okay, for number 8, you're going to take the rule and fill in the table, and that's all you're going to do is fill in the table. Notice the x values are given to you. Right? So this is using negative 3 in for the x, so it's negative sign, then negative 3 plus 4. That original negative sign was already there. Okay, and 2 negatives turn into positives. So positive 3 plus 4 is going to produce 7. Then you have negative 0 plus 4. Well, there's no such thing as negative 0. So essentially that part goes away. And 0 plus 4 makes 4. Then you're going to put in a positive 3 behind that negative sign. Now it's negative 3 plus 4. And that's going to produce a positive 1. Okay, so that's just completing a table once it's ready to go. Okay. For number 9, you got the same thing. You're completing a table, and again, the x values have been chosen for you. The rule has a fraction in it this time, so for some of you that tends to be a little bit difficult to use. Remember to use your calculator to do division and then multiply times the number you want to do. Right? So we want to do negative 1 divided by 4 times negative 8. All right? And what happens to that is that you end up getting a positive 2, because 4 goes into 8 2 times. Then we have negative 1 divided by 4 times negative 4. Well, 4 goes into itself 1 time. Then we have negative 1 divided by 4 times 0. Anything times 0 is 0. Then we have negative 1 divided by 4 times 8. Well, 4 goes into 8 2 times, but there's an extra negative hanging out, so this is going to be negative 2. If you use your calculator to your advantage, you can get all of that correct just by typing it in the right way. So make sure you know how to use that calculator. Right. For number 10, it's asking you which graph contains all the order pairs in the table. So start with the first one and rule out the ones that don't have it. We want positive 2, positive 1 to show up. So in letter A, if I go over 2, up 1, that's not on the line. A's out. For letter B, if I go over 2, up 1, again, not on the line. B's out. Letter C, if I go over 2, up 1, C's a possibility. For D, go over 2 and up 1, D is not a possibility. So just by checking that first order pair, C is the right graph. Okay, for number 11, we're trying to do independent and dependent variable again. Just notice that this time it asks for the dependent variable first and the independent variable second. Kayla works full-time as a waitress. She earns $7 per hour, an additional $4 per hour for each hour over 40 hours that she works per week. Right, that's a lot to register. But if you're looking at what you've got money and you've got time involved. So those are the two pieces. The dependent variable is her earnings, her money, what she earns. Okay, that depends on the number of hours that she works. Right? So time, remember, is always the independent variable. So her earnings, right, depend on the hours. Let me write that in a way you can read it. There we go. All right, for number 12, you're going to write your answer in the box and separate any numbers with commas. What is the domain of this function? Remember, domain refers to your x values. So that's all of these guys. But remember, you cannot repeat domain values. And also remember that you must have braces. So our domain equals in braces. The only numbers you need to write are 1 and 2 because everybody else is a repeat value. Okay, so know that domain is x and range is y values. All right, for number 13, we're going to go back to filling in a table, and from that table, we're going to create a graph. The rule for this problem is negative 2x plus 1. You get to choose your x values. Notice you have to pick 4 of them this time because you have to complete the entire table. Right, so I'm going to choose negative 1, 0, positive 1, and positive 2. You can choose any other numbers you want to, right, but those are going to be the simplest ones. Negative 2 times negative 1 is positive 2. Positive 2 plus 1 is going to give me 3. Put in the 0. Negative 2 times 0 is 0. 0 plus 1 is 1. Put in the 1. Negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. Put in the 2. Negative 2 times 2 is negative 4. Negative 4 plus 1 is negative 3. Right? So those are going to be your completed values. Now you want to put them on the graph and connect them to make a line happen. Right? So, and if it's not a straight line, you know you goofed in terms of plotting or in your table. So negative 1, positive 3, 0, positive 1, 1, negative 1, and 2, negative 3. Okay, and then draw your line and put your arrows. Okay, so that graph matches that table. All right, for number 14, a worm moves 2 inches every minute and is shown through the function y equals 2x. We're going to draw the graph that represents this scenario at 0 minutes, 2 minutes, and 6 minutes, and then create or connect the points to create a continuous function. When you go to do this, you have to set up your own table, okay, because it's specifically telling you that you have to figure out at 0 minutes, 2 minutes, and 6 minutes how many inches that is that the worm is moving, right? So you're going to plug it into y equals 2x. 2 times 0 is 0. 2 times 2 is 4. And 2 times 6 is 12. Right, now pay careful attention to the y-axis. Notice it's counting by threes. So this middle spot is a 6, then there's a 12, 15, 18, and so forth. Right, so now when you go to plot your points, you have to plot the 3 that are there and then draw a line to connect them. 0, 0 is very easy to find. 2, 4, go over to 2 and up 4. Now 4 is a little bit higher than the 3. Okay, so it's not quite on an actual intersection point, but it's there. And then 6, 12, you're going to go over 6. You're going to go over 6 and up to 12, which should be about right here. And then you're going to connect them. So you're going to start from the origin and make one continuous line going through the graph. All right, up at number 15. The graph shows Sarah's bank balance over the last 12 months. Which term can be used to determine her bank balance? Her bank balance is over here on the y-axis. Because it's on the y-axis, that label, because it's not referring to numbers, but that label is the dependent variable. Remember, your independent variable is the x-axis. Okay. For number 16, circle the box that you want to select. Below is a table of values for the areas of various circles. Which best describes the values in the column length of radius? So we're talking about the actual numbers in the column length of radius, right? And because it is the values in the independent variable, that is going to be the independent variable side, okay? Because it asks you to describe using... Sorry about that again. Because it was asking you to describe the column length of radius, right? That is a description, and descriptions aren't numbers, so that would be the independent variable because it takes the place of the X column. If it had asked you for the actual numbers in that column, then it would be considered the domain. So it really depends on whether it's asking you about the heading or the numbers that are in there. For number 17, we want to identify the dependent variable of the function. Remember, dependent is what depends on all the math to happen, and in an equation, the dependent variable is always the guy by himself. So in this case, it's the letter A. For number 18, okay, you want to circle all the correct answers. We want to show which is an example of a dependent variable. Dependent variable, remember, goes with your y values, your output, and your range. All three of those are synonyms for a dependent variable, right? So when we're looking at the first box, the y in the y equals 4x plus 3, okay? Yes, that is an example of the dependent variable, the y value is. If you look below it, the time axis in a graph of time versus distance. Time is always x, so that one is not it. When you go to the actual graph, the value of a car in the graph below. In a graph, the value of a car is on the y-axis, so that is the dependent variable. So this is definitely one we want to choose. And then in the table, the input column of the table, well, that represents the x, so we don't want that one. We only want the ones that are describing the dependent variable. For number 19, this is a graph of a line, that, or sorry, a V-shaped graph that keeps going forever in both directions. So even though it stops in your grid, know that it keeps going forever, never up through the ceiling, right? So we want to pick what is the domain of this function. Domain refers to x values. So if you look at the graph, all of the x values in the picture have a location on the graph, which means all of the x values are possible. And that's when we say all real numbers. There's nothing to stop or prevent us from finding a value on the graph. Okay. For number 20, we want to see which table has a domain of 3 and 5 and a range of -1 and 2. Notice that you can repeat numbers in your table, but the domain and range don't repeat. So in the X column, we're looking for only the numbers 3s and 5s. So the first one's okay, the second one does not have it, the third one does not have it, and the fourth one has other numbers other than a 3 and a 5. So just by knowing that the domain has to have only 3s and 5s, that makes the first table it. Okay. If you go to the next problem, looking at number 21, we want to identify which sets below belong to the range of the graph. In other words, in which ones of these problems can we find all of these numbers on the y-axis or on the line, right? So we're looking at y values, right? So -1 is right here. That is not on the graph, so we're not even going to look at any further at the rest of the numbers. So go to the next one. 1.5. We'd be positive 1.5. Can we go, actually it's better to do this. If you take the top dot and the bottom dot and draw it straight over to the y-axis, you are between the numbers of 1 and 4. So if you can say yes to any numbers between 1 and 4, then that's something you want to keep. So 1.5 is between 1 and 4, 2.5 and 3.5. All of those are between 1 and 4, so that's one we want to keep. Go to the next set. 1 is between 1 and 4, it is itself. 2 is between it, 2.5 and 3 are both between it. So all of those are in between that 1 and 4. If you go to the next one, 1, 2, 3, and 4 are all between 1 and 4. Okay, then if you go to the next one, -3 is not, so we can rule him out. And then go to the last one, 0 is not, so we can rule him out. So it's got to be between the lowest y value and the highest y value in your picture. Right, for number 22, right, we want to identify which representation matches the rule, and they gave it to us in words and in table format, and there's only one box. That's why it says box, not boxes, right? So we only pick one box that'll work. So check the table out. If I put 10 in the X spot, 10 times 10 is 100. 100 plus 5 is not 5. That rules the table out right away. Okay, then if we go to the next line, a zip line ropes course charges a fee of $5 plus $10 per hour. We don't know how many hours there are. So we have to pay the $5 plus $10 per hour, and that's going to equal our cost. And that looks very similar and almost exactly like the equation we have. So let's check the bottom box to make sure. 10 times a number means 10 times x decreased by 5. All right, well, there's no decreasing in this equation. So this box right here has to be the one that's going to match the equation. Right, for number 23, this is another rate of change problem. Right, so you want to set up the table. You have years and you have countries. and we want to figure out what was his rate of change. So we have the year 2008 and 15 countries, and then by the year 2015, he had visited 29 countries. So to get from 15 to 29, you're going to add 14. To get from 2008 to 2015, that's a positive 7. So we always want to do y divided by x, positive 14 divided by positive 7. That's going to equal 2, and we've got to have words because it's rate of change. 2 countries per year, which means in that time frame of 7 years, he was averaging about 2 countries every year that he had visited. Okay. Then on the last page, you are going to complete the table and then make the picture happen. So for number 24, right, they already gave us the x values, so your job is to plug them in. So if we do 1/3 times -3 minus 4, you can use your calculator to assist you. All right, 1 divided by 3 times -3 should give you -1. -1 minus 4 is going to give you -5. Right, when you put a 0 in there, 1/3 times 0 is 0. Okay, and 0 minus 4 is going to be -4. So that's that one. And then 1/3, or 1 divided by 3 times 3 minus 4 is going to give you 1 minus 4, and that's -3. So from those 3 order pairs, once again, we're going to graph the table on the grid and connect the dots to make the line. So -3, -5, 0, -4, and 3, -3. And then draw your line through them. Okay, so that's once again completing a table and then making the graph happen. Okay, for the next problem, last problem, you have 5 dots on this graph, and that's all you have are the dots, right? And it is asking you what is the range of the function. So remember, range refers to the y values, right? So you can either write all the order pairs out and then pick all the y values, right? Or you can just take and kind of eyeball on the y-axis what it's going to be. Okay, so if I'm using the y-axis, both of these 2 dots have the same y value. That's at +2. These 2 dots right here have the same value at +1, and this guy right here has a y value of 0. So the only answer you can pick are the numbers 0, 1, and 2. They are not connected, so it can only be individual numbers, right? If they were connected, then you would have said all the numbers between them, right? But because they're not connected, they are just individual numbers, right? So use this to help you out. A lot of the questions you see on the test review are very similar, right, to the types and pictures that you're going to see on the actual test. So use this to prepare yourself to get the best grade possible.